Good morning. Today we're going to talk about logarithms. I love logarithms. I hope you will as well. They seem a little bit intimidating, but once you get the hang of it, it's totally fine. So, when we're doing a question, let's say it was 2x or 2 to the x is equal to 8. All of you should know what the answer is. You should know what exponent that is. Okay? So x should equal 3. Now, if we're doing 2 to the x is equal to 6, we don't know what that is, but the only way to solve that is using logarithms. Now you can guess, like you know that it's going to be close to 3, so it'll be like 2.5 or 2.6, 2.7, 2.8, 2.9, something, and you can just kind of guess and check. But using logarithms, we are going to be able to find out what that exact answer is, and that's what logarithms are. They're very closely tied to exponents, and actually the answer to a logarithm is an exponent. Okay, so we're going to be working on these today, how to read them, how to write them, and everything else. All right, so b to the x is equal to y. Okay, now when you read this one, log base b of y is equal to x. I call it the wheel to change from log form, which is this one, to exponential form, which is this one. So to do the wheel, you just take b, the base. So the base of the logarithm will be the base of the exponent. Log base b of y is equal to x means that b is the base. The answer to the logarithm is the exponent. And then that equals the y. So if you kind of do the wheel and go in a circle, you can change from one form to the other form. Here we go. So to change to from log form to exponential form, we're going to do the wheel. We're not solving anything. We're just changing formats. Okay. So 2 to the 4th is equal to 16. Okay. Here, 4 to the 0 is equal to 1. And yes, that's a true statement. 12 to the first power is equal to 12. And then the last one, 1/4 to the negative 1 power. When it's a fraction, you must use parentheses. Because if you don't use parentheses, then the negative 1 only applies to the 1 and not the 4. So, your turn. Do the same thing. All you're doing is changing formats. There is no solving. You're just changing from log form to exponential form. Again, this is log form. This is exponential form. All right. Once you've done all 4 of those, please unpause the video so that you can play it and watch what the answers are. You should probably already know, but 6 to the 3rd, 7 to the 0, 21 to the first power. And normally we wouldn't leave this like this, just so you know, but we're just changing formats. Okay. Now, the negative 1, this has to be in parentheses. Okay, so to go back into log form, what I suggest you do is write log and then equals. And that's what I'm going to do for all of these. Log, leave some space, because you know you're going to have a base. Every single logarithm has a base. All right, so the base of the exponent is the base of the logarithm. The answer to the logarithm is the exponent. And so then the other place for that number is 25. Okay, 5 to the second power is equal to 25. So again, the base of the exponent is the base of the log. Base of the exponent is the base of the log. Base of the exponent is the base of the log. So log base 5, and that's underneath, that's a subscript, okay? So please don't use capital when you write log and then put the 5 here. Okay, so, and a lot of times I'll do it cursive, so this doesn't look like a 10. It doesn't look like 10G. So you got to be careful when you write the logarithm. And then the base, I usually kind of attach it to the bottom part of the G. So 5 to the second is 25. 10 to the, again, the exponent is the answer to the log. Okay, the exponent is the answer to the logarithm. This exponent is the answer to the log. And that means that the only other place left for this is here, 0.1. 4. Log and 4 are on the same line. So don't write it like this, log base 8 of 4. And like the 4 is raised, okay? The log and the 4 are on the same line. So is a 2/3. Same thing here. This is 1 over 216. Okay, so everything is actually on the same line except for the subscript, except for log base 5, that part. Okay, so don't raise it up like this. Please do the next 4. And then after you're done with them, play the video again. So pause it while you're doing those ones. All right, so you should have log base 9. That's a 2, so this is 81. So log base 9 of 81 is equal to 2. So the base is 20. The answer to the logarithm is -1. So this is 0.05. The base is 16. The answer is the exponent, and that would be 8. And then when you read this, it's log base 16 of 8 is equal to 3/4. Log base 20 of 0.05 is equal to -1. Log base 9 of 81 is equal to 2. So the base is 15. This is -2, and this is 1 over 225. Because you're basically saying if I take 15 and I raise it to the -2 power, I'll get 1 over 225. All right. Now there's some special ones here that we're going to talk about. So usually we can solve these, but this is the only one that's weird. When you have a logarithm equal to 0, or when you have log base b of 1, it's equal 0. Log base anything. So if I have log base 2 of 1, it equals 0. If I have log base 3 of 1, it equals 0. If I have log base 50 of 1, it equals 0. So log of 1, no matter what the base is always 0. Okay? All right. This one means that if you have your base of your logarithm and then this number are the same, then it equals 1. Or it equals this exponent. Let me just give you some examples of that you may want to write down. Okay? So if I have log base 4 to the 3rd, then these will cancel out and you'll get 3. If I have log base 7 of 7 squared, then these will cancel out and you're going to get 2. Which makes sense, right? 7 to the 2nd is equal to 7 to the 2nd. So that has to be a 2. Or 7 to the 2nd is 49, but if we rewrite that like that. All right, so the next one, if I have log base 9 of 9 to the x, then these would cancel and I would just get x. Okay, if I have log base 3 of 3 to the -2xy, then these would cancel and you would get -2xy. So if the base of the logarithm and the base of the exponent are the same, they cancel. Let me even give you one more example. If I have 4 to the log base 4 of 7 power, then this base and this would cancel out and you would get 7. All right, we don't really see that too often, but just so you know, if this base of the logarithm and this base of that exponent, when they're next to each other with the same number, you're going to get that. So sometimes when you do like log base 7 of 49, you just change that to log base 7 of 7 squared, and then you'll know what the answer is. All right, let's do some of these problems. So when you have evaluate, we're actually going to solve this. We're going to try to work it out. Obviously, we can't solve anything that doesn't have an equal sign, so we're going to put an equal sign in here. So there's 2 ways of doing this problem. I'm going to do it by doing the wheel. I'll show you a different way, but it doesn't really quite work great every single time because it's a little bit more difficult, but this way will work every time. So we're going to go make it equal to x. and then do the wheel. After I do the wheel, I'm going to either do that in my head, or I'm going to try to make the bases the same on each side. So I can make this 4 to the x, because that's what it is, and 64 is 4 to the third. Now, that means that x is equal to 3, right? By definition, x has to equal 3 to make it equal. So if these are the same, I can cancel them out. Now, you may have known that after the first step, and you can go ahead and write the answer in. Now, if you had rather done it like this, and take this and change it, and then do that, that's fine too. I'm not going to do it that way because it's not always easier. All right, so for this one, I'm going to make it equal to x. Do the wheel, 5 to the x. Now I'm going to make that into a fraction, okay? So 5 to the x, and that's 2/10. Hopefully you're not 2/10. That's a joke. I should put in laugh tracks into this if I could. All right, so that's 5 to the x is equal to 1/5. That's 5 to the first on the bottom, so 5 to the x is equal to 5 to the -1, because that's what that equals. If you want to make a fraction into a whole number, you make the bottom exponent negative, okay? So here, the 5s will cancel, and you get x equals -1. It's going to take some practice. Next. So 1/5 is equal to, or 1/5 to the x, excuse me, in parentheses, is equal to 125. So I want to make the bases the same. So I want this and this to have the same base. That base will be a 5. So 1/5 is 5 to the -1. We just did that. But I still have that x there. This is 5 to the third. All right, so when you look at this, 5 to the third is 125. So I know that that has to be a 3, but because I need it to flip over, I need to make it a -3. So these will cancel. You're going to get negative x is equal to 3. So x is equal to -3. And again, some of you might intuitively know that from the get-go. You're like, oh, I need 5 to the third, but I need that to flip over, so I need to make it negative. So if one side is a fraction, then one side is not, your x is going to be negative. Just remember that, okay? So if one side is a fraction and one side is not a fraction, the exponent will be negative, or the x will be negative. This side is a fraction, this side is not, so x is negative. Here, neither of them are fractions, so x is positive, okay? All right. So this is 36 to the x power is equal to 6. Now, neither of those are fractions, so x will not be negative. However, this one's a little bit more difficult. Some people may know this, some people may not. So what I'm going to do is I'm going to make this and this have the same base. And the base that I'm going to use is 6. And hopefully that's obvious to you. So 36 is 6 to the second power. But there's this x that's still here. Okay, so what I've done is I've changed 36 into 6 squared. And then on this side, 6 has to have an exponent also. Remember, everything has an exponent even if it's not there. Then the 6's will cancel, so you get 2x equals 1. So x equals 1/2. Now, why is x 1/2? Because 36 to the 1/2 power is a square root. And that's the only way to get 6. So you have to take the square root of 36 to get 6. The square root exponent is a 1/2 exponent. All right? So I would like you to pause the video, try the next 4 problems, and then replay this. All right, so hopefully you did these 4, and let's see how you did. So I'm going to make that equal to x. 4 to the x is equal to 256. After we do the wheel. And then we have to figure out 4 to what power is 256. When their whole numbers are a little bit easier to check or to figure that out. That's 4th, so x is equal to 4. And again, it's because these bases, once they're the same, can cancel out. For this one, 8 to the x is equal to 0.125. So 125 is 125 over, and then 1,000, because it's 3 numbers after the decimal. Okay, so 125, 1,000. And then if we reduce that, that's 1/8. So that's 8 to the first on the bottom. So that's 8 to the x is equal to 8 to the -1. So x equals -1. Probably no surprise, since when this book gives examples, this example up here and this example down here are very similar. Same thing with this and this. Okay. Next one, same thing. So we have 1/3 in parentheses, because it's a fraction, to the x is equal to 27. So they both have base 3. This is 3 to the -1. This is 3 to the 3rd. So -x is equal to 3, which means x equals -3. And then for the last one, you can probably figure it out if you look at that example. So 64 to the x is equal to 8. So this is 8 squared to the x equals 8 to the first. Or you can probably already know that that's a square root. So if you want to do x is equal to 1/2 there, that's fine. X is equal to 1/2. All right. So that covers that part of it. Now we're going to get to some stuff that we get to actually use our calculator for. So you need to make sure your calculator is ready. And we're going to be doing common log and natural log. Those are 2 parts that you can do with your calculator. Okay, so a common log is just log. Every logarithm has a base, just like every number has an exponent. Okay, so every single logarithm has a base. If that base is not there, then it's understood to be a 10. So if I just write log of 3, excuse me, that's not right. If I just write log of 8, then that base is understood to be a 10. Okay, this is called a common log. It's the one that you get to use your calculator for. Then the way you can tell what the base is if you look at the log button on your calculator and then you look above it, that's the base of your logarithm that you're using. It's 10, because the base of this exponent is also the base of that logarithm. Okay, when you use natural log, which is this one, and you look at the natural log button on your calculator, and don't say ln. I know you're probably going to say ln in your head. It's natural log. I think L is first, so it's log natural. Just kidding. So natural log. And if you look above it, you should have an e to the x. So the base of this exponent is the base of that logarithm. We just don't write it. Okay? So natural log has a base of e. We don't write log base e of x. We just write natural log of x. These are the same exact thing as each other, but we write natural log of x. Log base 10 of x, we write log of x. Okay? So these are on your calculator. You have the log button, and you should have a natural log button. All right? All right. So just put it in your calculator, log of 8. And you're basically, what they're asking you is 10 to what power is equal to 8. So it has to be a number smaller than 1, or would it make sense, right? Because if I had 10 to the first power, it would equal 10. So when you put this in your calculator, you don't have to do the wheel. Use your calculator. These are the only kind where if it says use your calculator, you're going to use decimal answers, okay? So if you put that in your calculator, you're just going to get 0.903. And if you want to check, you take 10 and you raise it to that power, and it better give you a number close to 8. Natural log of 0.3, negative 1.204. 3 numbers after the decimal, round it correctly. Log of 21, 1.322. And natural log of 54, negative 0.616. All right. Next, this is just a little bit of review from the top for all of these. It's not going to hurt you to try them, so please try all 12 of those. Just pause the video. It shouldn't take you that long to do them, and then you can come back and play this. All right? All right, so we're just writing this. Okay, so you're not solving anything. Just writing this in a new format, an exponential form. And again, make sure your exponents look like exponents. And make sure that your fractions are in parentheses. Again, so you're just rewriting in a different format. You're not solving anything, just rewriting. Okay, same thing here. We're going to write this in log form. So log equals. That's what I would do if I were doing these. And then the bases are 7, 50, 4, and 256. The answers are the exponents. So the answer to the logarithm is the exponent. And that only leaves one place for the other number. So that's 49, 1, 1/4, and 2. All right, so those are the answers to those. For the next group of 4, if you can do it without your calculator, then go ahead and do that. Like here, I don't have to use my calculator, although my calculator will work. Actually, no, calculator will only work. Well, some of your calculators will work. But if you have a base other than 10 or natural log, then I don't want you to use your calculator. So do this by hand. So 2 to the x is equal to 32. So that's 2. You should know this before I do this part. That's 2 to the 5th. X is equal to 5. And this one, if we do the wheel, we're saying 27 to the x is equal to 3. So 3 to the 3x is equal to 3 to the 1st. So 3x equals 1, x equals 1/3. Now, really what they're saying is 27 to what power is equal to 3? And that's 1/3 because you have to take the cube root of 27 to get 3. This, you're going to put that in your calculator. All right, so for this one, when you put it in your calculator, you should get 1.079. 10 to a number just bigger than 10, right? So you're trying to figure out 10, is that base to what power is equal to 12? And then for the next one, we have 0.75, and then we have a natural log of 0.75. And that should give you negative 0.288 if you rounded that correctly. All right. All right, next part. We're actually only going to do, actually we are going to do all the rest of these. We're not going to do the graphing. The graphing will be its own video. All right. All right, so here, if they have the same base, that's a 10. So these will cancel out. Here, we got to make the bases the same. So when there's an x here, you don't really want to do the wheel. So I'm going to make this log base 5 of 5 squared x. Okay, so this cancels with that, and you get 2x. Go ahead and try both of those. Again, this has a base of 10, even though it's not there. So the answer here is 18. And here, log base 4 of 4 to the 2x, those cancel, and you get 2x. All right. All right, for this next section, we're going to find inverse function. And in order to find inverse functions, we have to follow all of these steps every single time. Okay? You have to be careful, especially in this step, or in this step, actually 3 and 4 are going to be the hardest ones. And you need to make sure you isolate the logarithm or the exponent, and then you're going to switch formats. And you're going to switch formats just like we did prior. Okay? You don't always have to do step 1 because they don't always give you an f of x. All right? So there's no f of x, so step 1 is done. So we're going to go to step 2. X is equal to 6 to the y. Okay? So step 2 is done. Step 3, isolate the logarithm. There isn't one. So if it starts off as an exponent, it's going to end up as a logarithm. If it starts off as a logarithm, it's going to end up as an exponential. Okay, so you're never going to start as a log and end as a log. Okay, they're going to switch formats. All right, so the exponent has been isolated. Now we have to switch forms. So in order to switch forms, I'm going to write log equals. Okay, and then you have to place everything where it is. And sometimes the equations aren't written like you're used to. So the base of the exponent is the base of the logarithm. The answer to the logarithm is the exponent. And then that means x goes here. Solve for y, we've done that. So log base 6 of x is equal to y. Now remember, if I gave you that, you would do the wheel and you'd go, oh, 6 to the y is equal to x. Okay? Let me do one more, and then I'm going to have you guys do these down here. I think that the finding inverse is usually the part that people have the most trouble with. All right, so we don't have to do step 1. We're going to switch the x and the y. Isolate the log. So the log is by itself. You cannot move the 3 because it's natural log of all of this. Okay? If there weren't parentheses, you would move the 3 first because a logarithm wouldn't be by itself. Since that's done, we're going to change it to exponential. Okay, so when you're going from log to exponential, you're going to do the wheel. So this is the base. We need the base. The base of a natural log is e. Okay, base. The answer to the logarithm is the exponent. So the wheel's going this way. And that means that we have y plus 3 here. And since we're going to solve for y, we have to subtract 3. And not from the x up there, it's e to the x minus 3. All right, please try to the best of your ability all the ones that you can see here. So 3, 4, and 5, and then a and b here and a and b here. And then we'll go on from there afterwards, okay? So let's go ahead and try all of these. So how many, because that's 7 problems. And then I'll go over them with you. Do as much of it as you can until you get stuck. It's okay if you make mistakes. That's how you're going to learn. And then you can fix whatever you missed. All right. So hopefully you've done all these. You've paused the video long enough to try all 7 of these. And now I'm going to explain each one of them. All right. So change this to y. Next step, switch the x and the y. Next step, I need to isolate the exponent. So my exponent is here, which means I got to move this 2 over so I can get the exponential part isolated. So this is going to become x minus 2 equals 3 to the y. So I'm doing every single step that's up here in a different color so you know that what step I'm on. Okay. Next, I have to change formats. So it's an exponential form. I need to change it to logarithmic form. So I always find it easier to just write log equals. The base of the exponent is the base of the log. So 3 is the base of that exponent. So 3 is the base of the log. The answer to a logarithm is the exponent. Okay, so anytime you have a logarithm, its answer is the exponent of whatever was there before. And that means that we're taking the log of this. So x minus 2 goes here, and I'm going to put it in parentheses because I'm taking log base 3 of all of this. Okay, and then we solve for y, and y is already isolated, so that's your answer. Next, we don't have to change the f of x, so I'm going to change the x and the y. Next, I have to isolate the logarithm. So my logarithm is here. The 3 is not part of the logarithm, where if you remember in number 2, the 3 is part of the logarithm because it's a natural log of y plus 3. Here, the 3 is not part of the logarithm, and because it's not part of the logarithm, that means that I need to get rid of the 3 and move it over so I can get the log by itself. And now I need to change formats now that the logarithm is isolated, so I can do the wheel. The base is where you start. Okay, 2 to the x plus 3 power, so the log, it's going to go the other way, and then that's y. Okay, so that's the base. That's the base. The answer to the logarithm is the exponent. So this is the base. Answer to the logarithm, that's the exponent. Same thing here. That's the base. The answer to the logarithm is the exponent. Okay. So I have this, and then I solve for y, and it's already been solved for, but x plus 3, this whole thing, the answer to a logarithm is an exponent. That entire thing is the exponent. Next one, I'm going to change that to a y. Then I'm going to change the x and the y. Now I want to isolate the logarithm. This logarithm is isolated. That is a log. There's nothing else on this side but a logarithm. So now I'm going to change formats. So the base is 10 when it's not there. So that's the base of my exponent. The answer to a logarithm is the exponent. So the wheel is going this way. Same thing here. The wheel is going this way. Answer to a logarithm is the exponent. So x is the exponent. That leaves me with y plus 5. I do have to solve for y, and so I have to move that 5 out of there. So I'm going to have 10 to the x minus 5 is equal to y. All right, hopefully you guys are catching on to what we're doing here. We should have time in class or online to answer questions on these. All right, we are going to finish all the rest of these. So let's go ahead. Hopefully you did these 4 already, and then we'll do these. And those will be the last ones because then afterwards it's graphing, and I'm going to put graphing in a separate video. All right, so y equals 8 to the x, switch the x and the y, and then write it in log form. So log base 8, answer to the logarithm is the exponent, so x goes here. Next, x equals the natural log of y plus 3. Isolate the logarithm, so x minus 3 is equal to the natural log of y. And then change into exponential form. The base is e. The answer to a logarithm is the exponent. And then that equals y. If you prefer to write that natural log of y equals x minus 3, so you could do the wheel this way, then that's fine also. Next, y equals 11 to the x minus 2. Change the x and y. Isolate. So we got to get this exponent by itself, so we got to add the 2 over. And then we'll change that into log form. So changing it into log form, base of the exponent is the base of the logarithm. The exponent is the answer. So that means the x plus 2 goes here. And then this one, we're going to make that x equals log base 3 of y minus 5. You got to get that logarithm isolated by itself. So I'm going to add the 5 over. And then I'm going to change that into exponential form. So that's going to be 3 to the x plus 5 is equal to y. base, answer to the logarithm is the exponent, and then that's the only place left for that. All right, again, this is more review. Please try these. I don't think you can have too much review with logarithms. We're going to do these 6, and then that's it. All right, those cancel, and we get x. Those cancel, and you get negative 3x. Again, hopefully you tried these already. Here I have log base 2 of 2 to the, that's going to be 6, because 32 is 2 to the 5th. It's 1 more 2. So that's 6x. And then e, natural log has a base of e. Those are inverses of each other, so they cancel. And you get 20. And then these are just 2 more inverse problems. We just did a whole bunch of them. You should be an expert by now, I would imagine. Just kidding. All right, so we're going to change it into log form. Base is 4. Answer to the logarithm is the exponent, which is this one. And so x goes here. And then the last one, x equals the natural log of y minus 5. Change. Now we got to change the format. Natural log has a base of e. So e to the x is equal to y minus 5. So e to the x plus 5 equals y, because we have to solve for y at the end. All right, so hopefully that helps. That's it for 5.2. The next part, which is all graphing, I'm going to put that with section 5.3. So all the logarithm graphing stuff is together in one video.